Welcome back, week 3, day 2. Today we're going to continue practicing what we saw the last class, solving systems using substitution. I have 3 systems over here. We're going to solve each one of them, and we're going to see what type of solutions we have. Remember, we have 3 types of solutions. One solution when we actually have a value of x and a value of y, and that would be our order pair x comma y. No solution when something is not true, like 0 equals to 1, 0 is not equal to 1, and infinitely many solutions when we get an identity like 1 equals to 1 or 0 equals to 0. And that is what we're going to see, what type of solution we get by substitution. Okay, so let's begin. Remember, the first thing is to call an equation equation 1 and an equation 2. Then we need to find a substitution. Okay, in other words, we need to find an equation that is easier to leave one variable completely alone and positive on one side. Sometimes, like in this case, it's already given. We see equation number 2 has already the y completely alone in one side and positive. So what are we going to do? We are going to substitute this that y stands for in the y of the equation 1. Okay, so we're going to have 6x minus 2, and instead of y, I'm placing what y stands for in equation 2, which is 3x plus 1, and that is equal to 10. We solve this. We have it now only one variable in our equation. We solve this using distributive property. So we have left 6x. How much is negative 2 times 3x?
Negative 6.
Negative 6x. Negative 2 plus 1. Negative 2 plus 1?
Negative 2.
Negative 2 is equal to 10. Now we simplify 6x minus 6x.
0.
Zeros, or I can cancel them out. What do I have left? Negative 2 is equal to 10. Is negative 2 equal to 10?
No, it's no solution.
Exactly. This is a no solution. So you don't keep doing anything else, but tell me no solution. Okay? You need to place it. Okay? You need to say this is no solution. Why? Because negative 2 is not equal to 10. Okay, so you place no solution, and then you say negative 2 is not equal to 10. Remember, not equal is the equal sign with a cross line like that. Okay, that means not equal. Okay, we good? We clear so far? This is what you're going to get when you get no solution, something that is not true, like negative 2 equals to 10. Okay, let's go with the next exercise. We got y equals 1/2 x plus 4. We got negative x plus 2y equals to 8. Again, this is equation 1, and this is equation 2. Now, let's look for an equation that is easier to leave a variable alone. What do you think in this case?
Negative x plus 2y equals to 8.
It's easier to leave a variable completely alone and positive on one side? No, Benitez? Which one is it then?
It's
already given. Equation 1 has the variable y completely alone and positive already. So we're going to substitute inside this y what y stands for. Okay, so we're going to say negative x plus 2, and instead of y, I'm going to place 1/2 x plus 4, and that is equal to 8. Okay, we're going to do the distributive property. Okay, and we get negative x 2 times 1/2
2 half.
Halves. That means 2 over 2. And 2 over 2 is equal to what?
1.
To 1. And do I write a coefficient 1? No, right? So I just place plus x. Then 2 times 4.
8.
So plus 8. Josephine. And that is equal to 8. Josephine. Let's simplify. Negative x plus x.
0.
0. So I cancel that out. And what do I have left? I got 8 is equal to 8. How many solutions do I have then?
1 solution.
One solution.
8 equal to 8. An identity.
So it is not one solution. It is infinitely many solutions. When you get an identity or when you get something that is completely real, like 8 is equal to 8, you say that you have infinitely many solutions. If we graph this, if for any reason we have to graph this, you will see that the lines are exactly the same. Once that you graph it, you're going to get the same line graphed, okay? The same line over the same line. Questions? Carlos? No questions? Okay, so let's go with the very last exercise. I'm going to move it a little bit to the side. And again, equation 1 and equation 2. It's always easier to identify them like that, okay? So again, what equation is easier to use as a substitution?
The first one.
The first one, okay? So we're going to substitute inside this M what M stands for, okay? So we're going to have negative 6n plus 8. And instead of M, the place where we have on the first equation, 4n plus 11. And as you can see, the equation has only one variable now, okay? They're now in terms of the variable n, and that's what we're trying to find out, to find an equation that's in one variable only. Now we do the distributive property, okay? And we got negative 6n, 4n times 8
32.
plus 32. 32 what?
And
32n. 8 times 11,
88.
so plus 88 equals to 36. Okay, now we're going to simplify. How much is negative 6n plus 32? Mhm.
26 and
26
26.
n. Are you sure it's 26? Yes, it's 26n plus 88 equals to 36. Now we need to leave the variable alone. So this constant goes to the other side, subtracting. And we have 26n equals to 36 minus 88. How much is 36 minus 88?
52.
Negative 52.
Thank you, Hennis. It's negative 52. Don't forget the signs, okay? Negative 52. Now I leave the variable completely unknown. So this 26 passes to the other side. Doing what?
Dividing.
Dividing. Okay, so I'm going to have now that n is equal to negative 56, negative 22, sorry, divided by 26. How much is that?
Negative 2.
Negative 2.
N is equal to negative 2. We got the value of n. What is the next step then? What is the next step?
Find the value of m.
The value of m. How, Josue? How am I going to find the value of m? How am I going to find the value of m? Mauricio? How am I going to find the value?
Using the first equation, but substituting n to
Very
negative.
good. Very, very good. We're going to substitute the value of n inside the first equation, okay? So my first equation is m equals to 4. Instead of n, I use -2 plus 11, okay? So m is equal to, how much is 4 times -2?
Negative 8.
Negative 8.
-8 plus 11,
Positive 3.
+3. How many solutions do I have then?
Now this is one solution.
Now this is one solution. And what is the solution? In this case, we don't have x comma y. So what is the solution in this case?
I guess it's 3 comma -2.
3 comma -2y. Why is that?
I guess it's by alphabetical order.
Exactly, because we need to follow the alphabetic order. So it is m comma n, because in the alphabet, m comes before n. So yes, it is 3 comma -2. And there you go. One exercise of each, one example of each type of solutions that you might have. Once you get to this, you don't do nothing else. Once you get to this, you don't do nothing else. Once that you get to this, you substitute that value into either the equation, the original equation that has the variable completely alone that you substituted in the first place, or into the new equation that you found, in, like we did in the previous day that we had classes, okay? And you have to follow an alphabetical order if you don't have X, Y, okay? You follow the alphabet order. Questions so far? No questions? Okay, then this is what we were going to see today.